In this video, we're going to talk about derivative rules to know when taking Calc 1. If you come into a calculus course knowing these derivative rules, you're going to have smooth sailing the whole semester. So the goal is maybe not to know every single rule by the end of this video, but at least be familiar with some so that it's not surprising when you get to the derivative sections of calculus. So our first derivative rule is the derivative of every constant. If you have a constant, the derivative is going to be 0. So next door we have ln of 2, which is a constant. 2 pi to the 5th is a constant. Minus e squared is a constant. All these are just numbers. They don't have a variable with them, so their derivative is 0. You could plug that into a calculator, add it all up. It's going to be a number. Derivative of every number is 0. Derivative of e to the x is e to the x. So anytime you see an e to the x, its derivative just ends up being itself. There is the limit definition of a derivative, and somebody did this over and over and realized that, hey, when I do this limit definition, I get the derivative of e to the x is just e to the x. If we change bases, though, and we have like 5 to the x, anything besides e, which is about 2.7, if we have any other number to an x, and that's assuming that number is positive and not equal to 1, just thinking about properties of exponential functions with different bases. They're always positive bases and they're not 1. The derivative ends up being ln of the base times the base to the original power, ln of a times a to the x. Or if we put a number to it, the derivative of 5x is going to be ln of 5 times 5 to the x. The derivative of the natural log of x is always 1 over x. So anytime you see ln of x, you get 1 over x. Where that comes from is covering up the ln. You take the derivative of what's inside derivative of 1x is 1. We're going to see why that is, and the original inside is x. So there's a couple ways to think about any ln rule. But we can just remember the natural log of x has a derivative of 1 over x. The natural log is base e. If we have a log of different bases, so if we have any log base b, so it might be log base 5. In general, it's going to still be that 1 over x, but you're going to have ln of your base in the bottom as well. So 1 over x ln of b. We're going to keep that in mind. We're going to look at log base 5, which would have a derivative of 1 over x ln of 5. So those are some of our exponential and log rules. In general, you'll have a lot of polynomials to work with. So it'll have x's to a power. To take those derivatives, you'll bring down the power and subtract 1 for the new power. So if we apply that to a number, we have this x to 100. We're going to bring down the 100 and raise x to the 100 minus 1 is 99. When you do that bringing down of the power and subtracting 1 for the new power, you're going to see a pattern when you have x to the first. So I call this a mini rule. If you bring down x to the first, you would keep that k, bring down the first power, and subtract 1 for the new power. You'd get x to the 0. Anything to the 0 power is just 1, so you get k times 1 or just k. So a mini rule is if you just have x to the first power, your derivative ends up being the number out front, the coefficient with it. So the derivative of 55x is 55. Now that we've listed these rules, we're going to actually use them a few times down below here, and that should help it make a little bit more sense just with some practice. So we're going to go down some basic derivatives practice. We're going to put in a constant multiple, which doesn't change how we take a derivative, and then we're going to do some sum and difference, which also doesn't change these derivative rules. So starting with just a basic derivative, we have x to a power. Any x to a power, bring down the power, subtract 1 for the new power. So our derivative notation, the derivative of h is h prime. And we're going to bring down the 19, subtract 1, and get 18. That rule does not change even if you have a constant multiple with it. So here we have an h where we're going to take the derivative, call it h prime, and we still are going to bring down the power and subtract 1 for the new power when we have x to a number. So 10 times 9, when I bring it down, is 90, and we're always subtracting 1 to find our new power. So 9 minus 1 will give me 8. None of these rules change if you have things added or subtracted to them. You're just going to treat each term individually, taking those derivatives. So we're going to find h prime of x again. I have x to a power, so I'm going to bring down the power. 2 times 7 is 14. My new power is going to be 7 minus 1, which is 6. I have another derivative rule here. I'm going to keep the constant multiple 3, just like we have been. We've been keeping and taking derivatives. So keep the 3. Derivative of e to the x was always e to the x. And then we have this mini rule here. Since we just have x to the first power, derivative of 7x is 7. Our last term, derivative of pi squared. Pi squared is a constant. Its derivative is 0. If it helps, you can label it for yourself. There's not going to be a derivative of that last term because the constant has a derivative of 0. All right, let's keep practicing, see if we can see some patterns. Calculus is a study of patterns. The more you do it, the easier it'll get. We'll start to pick up on some of these patterns. So the derivative of the natural log of x is always 1 over x. If we have a constant multiple, all we do is keep the constant multiple and take derivatives as usual. So above, we kept the 10, we brought down the 9, and that's how we got 90x to the 8th. But for ln of x, you don't bring down a power. The derivative of the natural log of x is 1 over x. So 14 times 1 over x. We're going to combine that with some adding or subtracting. It doesn't change how we take a derivative. We're going to keep that 3 and take the derivative of x to the 9th. So 3 times 9 is 27. 9 minus 1 is 8. So bring down the power, subtract 1 for the new power. We're going to keep the 6. The derivative of the natural log of x is 1 over x. And then ln of 4 does not have an x with it. It is a constant. You could plug it into your calculator. It's just some decimal. The derivative of every constant is 0. Our next piece, we have 4 to the x. If it's e to the x, the derivative is just e to the x. Derivative of 4 to the x is not just 4 to the x, though. It's close. It's ln of 4, then it's the 4 to the x. The next one, we have a constant multiple. It might not feel like it, but we want to remember that you can never take a negative base to a power. So this must really be like -1 times 8 to the x. So when we take the derivative, we're going to have that minus out front because we have a -1. We're going to keep that. We're going to do ln of our base to the original power. So you can write that as -1 or just a negative out front. Derivative of 4 to the x is ln of 4 times 4 to the x. Derivative of 8 to the x is ln of 8 times 8 to the x. We can combine that and practice some more rules. We're going to find f prime of x next door. We're going to keep the 5, bring down the power 3. Bring down the power, 5 times 3 is 15. Subtract 1 for the new power. So we're going to get 2. Next, we have 2 to the x. Derivative of 4 to the x was ln of 4 times 4 to the x. So derivative of 2 to the x is going to be ln of 2 times 2 to the x. And then derivative of e to the x is always just e to the x. And e cubed is a constant sneaking in there. Derivative of every constant is 0. Doesn't have an x in it. And we'll do one more line of practice. We have the derivative of log base 4 of x. Derivative of the natural log of x is 1 over x. This is log base 4, so it's going to be 1 over x ln of 4. And lastly, for our constant multiple rule, we're always going to keep it, so you can just keep that 10 out front, or you can put it right in the numerator, whichever you'd prefer. I'll keep it right out front for now. 10, and I'm going to take the derivative of log base 3, so I'm going to do 1 over x for any log, and then this is going to be 1 over x ln of 3, since it was base 3. And our last sum or difference example, I hope you've been pausing the video throughout because you might need to take a second, take in which rule it is, or maybe listen to this twice or take notes twice. There's a lot going on here, learning all these rules at once. The derivative of f is labeled f prime. Derivative of 10x, that's our mini rule. Derivative is just going to be the number out front. So 55x was 55. Derivative of 10x is just going to be 10. Plus we have a log, so I'm thinking 1 over x. Since it's log base 6, it's going to be 1 over x ln of 6. And then we have minus 1.62, and 1.62 is a constant, so that derivative is 0. So that is a preview of a bunch of derivative rules for Calc 1. There is going to be another video that goes through trig and inverse trig videos. Feel free to watch that, but you might want to watch this one a couple of times or make some flashcards out of these so that you can have some of them down before starting the derivatives unit in Calc 1.